Yo, so here's my practice demo on what we're gonna be doing in class. I got my syringe here with hot water in it, and here's what you wanna talk about. Before you even get to the demo, we're gonna ask the class, all right, everyone, so what do you think causes water to go into a gaseous state, and when does it happen? And the class is gonna say things like, oh, it's based on the temperature of the water. And you're gonna drag onto that. You're gonna be like, okay, the temperature. What is temperature? And they're gonna be like, energy. And you're gonna be like, yeah, it's energy. Energy in the water. It's when you add energy to the water. And when the water has enough energy in it, it gets all excited and escapes into a gaseous space. And as you know, the gas, we can move through gas really easily. It's a little bit harder to move through water. And that's because there's a lot less distance between each particle when it's in a gaseous state, because it's flying and moving around. And you've seen depictions of atoms before, so you can kind of talk about that. And then you'd say, but here's the interesting thing. It only does that in the circumstance of our atmosphere on the Earth. On the surface level or ocean level of the Earth, the atmospheric pressure at the number that it is keeps the water at the level that it is. It makes it so that it can't escape into a gaseous form until a certain level of temperature is hit. But, that's described by the 100 degrees Celsius. That's the limit. But we can make it so that this 100 degrees limit goes down by decreasing the pressure. And if you remember last time when we were in class, we talked about pressure and volume and all that kind of things with the candle experiment, and we're doing something similar here. So if I were to seal this water, this warm water, in this syringe, and then pull this up, that is going to increase the volume and decrease the pressure. When we decrease that pressure, it makes it so that the barrier of energy, or the temperature that the water needs at to start boiling and turn into a gaseous state, is lower. It doesn't need as much energy to escape into the atmosphere in the syringe. Now, the moment you expose this syringe to the atmospheric pressure of the ocean level at the surface, the rule of 100 degrees Celsius goes back to what it is. But in here, you don't need to be as hot. And we can see that when we pull on the syringe, and immediately we start getting some bubbles. It starts boiling. How cool is that? And you can just talk about how, as you can see, this water and the energy levels in the water are now sufficient enough to turn the water from a liquid to a gas. And that's the experiment.